I am AI. Accelerating your discoveries to solve the great challenges of our time. I am a visionary, bringing characters to life with more natural movement, generating brilliant new worlds for them to explore, and inventing new ways to bring out the creative genius in us all. I am a protector, leading the way into the most dangerous environments and searching for signs of life. I am a guardian, listening for the sounds of destruction to save our forests, and using satellites to bring freedom to those who are enslaved. I am a navigator, finding safer paths for cross-country deliveries and taking personal travel to new heights. I am a scientist, exploring oceans of data to understand extreme weather patterns and studying the building blocks of life to save a community from hunger. I am a healer, giving hope to those who suffer from the most challenging diseases. And tapping into the brain to rejuvenate paralyzed limbs. I am even the composer of the music you're hearing. I am AI, brought to life by NVIDIA, deep learning, and brilliant minds everywhere.
Let me introduce myself. I am Anish, and I manage the industry vertical at NVIDIA based in Singapore. And thank you for FPD to help me provide this platform to speak about NVIDIA. This is where the industry is changing now, and believe me, Vietnam is not an exception. You're also part of it. The computing industry is changing where the CPU computing has already hit the roadblock. It is not increasing the speed for last 10 decades. Whereas you have the GPU computing in the green that's growing by 1000x. So you have one GPU equal to 1000 CPU. Parallelly, if you see, what's happening is there's a new breed of technology called as AI, where the computer or the software is learning from the software. No longer you have someone sitting behind and doing the manual work. The software is learning from the software, which we call as deep learning. Now, this is a complex computing problem, and this whole problem is changing the face of the industry. So when you look at the AI solution, when you speak to Alexa, when you speak to your Siris on the phone, they revert to you immediately. When you do a Google search, it reverts to you immediately. What are they running on? They're running all on GPU behind the scenes. So this is what NVIDIA does. So we primarily create platforms for AI. So these platforms, like, definitely everyone knows us from gaming. GeForce is a big brand from us, but that's a gaming business. But we create a lot of platforms for high performance compute, for autonomous vehicle, transportation, healthcare, AI industry. Like here, many of you are from the finance industry. So we create a lot of platforms for it, which is utilized to build solutions across. And all these platforms runs on one key heart and soul of the entire computing, which is called as a graphic processing unit. Trust me, it is no longer called as graphic processing unit. It is called as accelerated computing. So you can have the unit, whether it's on your under the desk, which is Quattro we call it, or you might have something on which is inside the data center, which you call as a DGX, or you might use it on the cloud, which is a hyperscaler called HGX, or you might have something as an embedded inside the car, autonomous car, inside the robot, moving the hands, inside the camera, doing intelligent analytics. This all runs on an embedded GPU. So this is where finance, as an NVIDIA, when we look at it, AI is a horizontal story, but they're also vertical story. So you might call it as artificial intelligence, someone call it as data science, but in NVIDIA we throw it into three different tabular formats. Analytics, it is basically where you do a lot of graph, lot of tables, lot of dashboarding that you do it. Like for example, your boss asks, okay, tell me what is my total fixed deposit collection for this month. Now you run that report, it takes you 3 hours, 4 hours to run the report. Now this can be done in 1 second. That's how fast the GPU can do it. When you look at machine learning, now machine learning, for example, when you do bond pricing, if you're an investor, if you're into treasury, you do bond pricing, they use machine learning. Or coming to the last part, the new breed of technology called deep learning, where you might be looking into investment trading, you're looking into OCR solution. You click, take out, open the FPT app, click a photo, and your bank says, yes, it's an authentic face. It says, yes, you are the real person by checking into your national ID like a passport or an ID card that you click across. There's no one sitting behind and doing it, but it is all the artificial intelligence product which FPT builds using NVIDIA libraries and hardware behind it to deliver the solution. So that's what we call as deep learning. Let me get you some use cases. Now I want to expand the horizon. How does the finance market look like? So this is an example of Scotia Bank. It's a very well-known international bank, where what they do is they used to take a lot of data to do compute-intensive risk tasks. Now when they run this report, analytics, you have an analytics team, they take 6 hours to run the report. Now suddenly the market risk changes every second. The market moves every second. Dong versus USD moves every second, So all these movements are real time. So you need this data real time for a trader to act immediately. How can you do it? He uses an in-memory GPU solution which can query millions of tables with billions of rows, with billions of columns, queried real time. Think about Vietnam, 140 million population. Probably everyone owns 5 relationships with every bank: credit card, loan, salary account, children's account, minor account, whatever you want to call. Now these are data, so it's almost like 450 million accounts with sub-families of accounts that you want to do. That's kind of data that we do real time. Similarly, when you look at this, now today you have this robotic reinforcement-based investment solutions. So your bank might be selling you a portfolio management solution which is robotic. Now if you see this, they capture real-time data using deep learning, which is again AI, on NVIDIA GPU plus the software stack on top of it to give you a better return. So if you see, that is a benchmark for global allocation funds, and this is a deep learning solution used by one of the companies and showing everywhere the return is 17% compared to what 14% you get it across. Trust me, all of us in this room will like this money, right? So this is where it gives you a bigger return using AI. This is A very common use case, PayPal. So this is like a payment wallet. Every country has their own localized pay wallet. PayPal is a worldwide pay wallet that you see. The bigger challenge is you lose millions of dollars on fraud. Some transaction you didn't do it, suddenly it's a fraud, right? Now today, banks, PayPal, pay wallets are looking at this solution using deep learning to reduce this loss. It's a simple calculation. If I invest something to save $1 billion of DOM, it's a good investment to make. That's what they're doing. The way they do it is they use NVIDIA libraries, NVIDIA GPU, which is very, very fast, and they query the fraud, which is 8x faster, and which has increased, in fact, decreased the server sizing by 10%. That's what NVIDIA brings. That's what the value that we added across. Again, example, taking the same bank, Scotia Bank, look at a credit card. All of us own a credit card, debit card. I'm assuming all of us have it, some sort of payment card. You have to make a payment on the 45th day when the payment of the credit card is due. And it is human tendency, you tend to forget when you have to pay, so you have to pay a fine if you don't pay it by a day. So Scotia Bank is trying to improve the experience where they look at the trends of your payment. When have you made a payment? What are your other relationship payments? These are data at the end of the day that you have at the bank. So looking at this trend, and they're trying to forecast and understand, okay, this guy might be missing a payment. So whether it's an email, whether it's a call, kind of a mechanism to remind him. So that's what they're using deep learning for. This is very, very important. The customer is happy, you pay on time. The bank is happy, they get paid on time, right? So everyone invests in this kind of experience which is there. The most important is today, business is becoming more customized. Everyone is treated in a customized way because of technology. That's what AI is bringing to the table. Now this is to do with the customer service operation, very similar to what FPT, they're trying to do the call centers here, trying to automate using natural language processing. This is an advanced form which you'll see across where you can do banking to chatbot. When you speak to the chatbot, definitely you have the natural language processing as an API working, but this is integrated with the entire console like Salesforce.com, because that is where your entire business pipeline, everything is there. All these are integrated and compute using NVIDIA, which is there used across. This is a live example in ASEAN region itself. I can't name the customer entirely because I'm not allowed to name the customer. So this is an insurance company. Today the challenge was whenever your car gets hit or into an accident, you have to take the car to a garage, call the insurance company, who will send a valuer to look at the car, then they look at the valuation, and then whatever the valuation of insurance money comes, you get that money. But they realize 20% of the transaction, which are less than $5,000, they cost 80% of operational cost. So 20% of my claims, because someone calls up, you need someone behind the phone, take it, someone to do that paperwork, send a valuer to that place, these are costs. So they realize it takes 80% of the cost, which is making them incompetitive to the competitors. So what they're trying to do it is very simple. I hit my car, took my phone, clicked, it's my bonnet got bent or whatever it is. These are trained and it goes directly onto the web portal. Within 5 minutes, it's approved and you can just drive your car to the garage and get it right. 5 minutes with the use of technology, using like computer vision technology. So they have a lot of data which they have trained in a neural network to do this. So this is exactly in 10 minutes or 5 minutes, they can close an insurance. Yes, the higher value insurance requires a scrutiny, which is okay. That's more risky, but that takes only 20% of my cost. 20% of the job takes 80% of the cost. I'm able to reduce that 20% to 5% of my cost. That's where efficiency, that's profitability for a bank comes in. This is the local example. This is exactly what Dr. Wade's team does it across. So they build the entire platform, whether they build natural language processing solutions, which they deliver to as an API, or whether they give you a vision-based solution like the OCR, eKYC solution that they build, or the autonomous vehicle that's running outside. They all run on NVIDIA frameworks, the libraries that we generate, and also on the GPU, which is the computing unit. That's exactly what FPT does. They create beautiful AI platforms to build products for you to use it across. Another use case that you are already seeing it, this is already started deploying by them. So this is your real-time face matching. So I want to open an account, I just take my photo and I can do as an e-account. So it matches my face to the photo without any human intervention. That's what FPT vision technology, face matching technology does. How they use it? They use an AI appliance for training those data. When they deploy that API, the API runs on an NVIDIA GPU again. That's where they use it across. Another example, sorry, I have to mask a lot of data. I don't have permission to use the personal data of people. So this is where you have your Vietnamese ID card, passport, right? So how do you do an OCR? My card here, my photo here, I take it. But this card would have been issued 10 years back. I ride a scooter day in, day out to office. It rains, it's all got blurred. My picture is blurred, right? My names have gone old, right? But still I'm able to match. How? It's because the FPT AI team has developed this OCR technology using NVIDIA computing and the libraries to do this solution. If it is a very clean country like Singapore, my ID card looks new all the 5 years. It's easy. But when I'm in Vietnam, I'm going to the office, I have sweat, I have my wallet, all things get blurred, right? But you need a technology which can identify. That is what exactly FPT is providing it. And trust me, this provides you localization. Because you're not using English, you're using a local language. That's where the benefit of a homegrown technology comes in, using NVIDIA solutions like DGX. But how does this work? All the very fascinating stories that I told you. But what is the heart and soul of how it works is, this is how it operates. So when, for example, FPT, when they build the technology, they use an NVIDIA libraries and tools to build those fabulous technology, the developer do it. They train the data on an appliance called as a DGX, which is a AI appliance, something called as a supercomputer, which is there where they train the data, because they collect the data, they train it on that, and after they have developed, when the bank implements, they don't use this, they use inference, which is running on a low-powered GPU on a server, which is called T4. So this is a technology that runs behind. Now this can run on the private cloud of Test, this can run on the public cloud, this can run on-prem, GPUs everywhere. This is how it runs across the entire aspect. This is how the DGX, now DGX is just not a hardware, it's an appliance. So what NVIDIA does today, when you look at AI is a different animal altogether. I'll say there's an animal because the framework, the OS level, all are open source. Now today, you don't have anyone here who can do customizations of Ubuntu, customizations of those TensorFlow, Caffe. These are the terms that AI guys use it. What NVIDIA does, we spend more than $3 billion worldwide in R&D trying to optimize this. That's exactly what Google uses, that's exactly what FPT uses, that exactly as a customer you use it, exactly at home you use it across. These all are optimized, and this goes across platform in a container Dockerized format. I don't want to go technical here. People who are technical will understand, they can Google later. But the concept here is, it's an appliance. Just bring, plug, play, train your data. That's it. You need not need an IT guy to do configuration, no. If you don't even have a DevOps guy, it is perfectly fine. All of this, we made it very simple. That's exactly NVIDIA calls democratization of AI. This is how it looks like. So this can be a 3U box, this could be a 10U box, depending on the volume of data you have it. And this is the world's fastest supercomputer, which you might think it's as big as a room. No. How it looks is just a 10U, that's it. That's it. So this is what we do. So this is your traditional data center. The entire data center gets replaced by one box for AI because you will have data. Data will increase. You will need more and more computing. Today you're doing OCR. Tomorrow you will do more use cases that will have more data that you want to look at it. These all doesn't mean that you have to keep on investing on data centers. No, these all run. So if you see here, this kind of solution requires $3 million USD. This is 1/8 of the cost, 1/16 of the space, 1/20th of the power. That's the kind of level that we speak across. And this is where when you deploy. So if you're a bank, you don't need that. What you need is this. So today you might have different AI solutions running. Something could be OCR, something could be risk management, something is trading, something is analytics. It doesn't mean I create a different silos for differently. No. You just create one consolidated infrastructure depending on how much data you churn and you inference, and you just do a scale up. So every kind of use case of AI runs either on a small GPU like that, or for a bank, or for a big bank like this, So depending on the kind of data you have is how we utilize it. So that's it from my end. I'm more than happy to around if you have any questions later on. Otherwise, thanks for your time.